A good day to you. In this tutorial, we are going to be revising the chapter on loan schedule. So we are going to look at past exam papers and how to answer in an exam. So when attempting past exam papers during your revision or even in your exam, when attempting questions, you are going to be doing that in Microsoft Excel, in Microsoft Word, sorry, for paper 1, CM1. So make sure that you revise using Microsoft Word. Don't revise using pen and paper because you won't practice on speed and how to type. So revise using Word, and also make sure that you use the correct notation. The examination handbook is very handy in helping you in helping you in knowing the notation to use. For example, as you can see here in the examination handbook, it has some formula, some Microsoft, some formula that's useful, some notation, general mathematical notation, and then the standard keyboard symbols that can be used in an exam. So make sure you familiarize yourself with this, and you can use this in Microsoft Word. So we'll start with our first question. Our first question is from April 2019 paper, question number 12. April 2019, question 12. It reads, a loan of £80,000 was taken out on 1 January 2016. The loan was to be repaid over 10 years in level installments, payable monthly in arrears. Calculate the level monthly installment using an effective rate of interest of 6% per annum. So the first thing that we do is we want to calculate the level monthly installment, and the loan is for 10 years. So we can use the equation of value to do this. We can use the equation of value. So this is question 12, and this is part 1. Part 1. So using the equation of value, if you are to be writing down on, sorry, this is part 1. If you are to be writing down your answer on paper, you would write it as, okay, let's start with the first part. So we let R denote the level monthly installment that we want to get, level monthly installment. So our equation of value, if you are to be writing it on paper, you would write it as 12R times A10, because this is an annuity, A10, 12, because they are paid monthly, and it's for 10 years, is equal to 80,000. And where we have your interest rate is equal to 8%. So if you are then to type it out, you'd then write in an exam, you'd write 12 your times, you can use these times, then A 10 12, this you'd write it as A, then 10 in brackets, then this column, then the 12 would be like 8, sorry, this is a 12, 12, yeah, it's paid 12, it's paid monthly. Then the 10, which is the period, would be in these type of brackets to show that this is a period, and this is equal to 80,000. So if you go to your tables, you can find a 10. So from your tables, anything that I'm writing using the pen would not be written in an exam because you don't have a pen. So this a 12 10, you can then write it as, this would be 12R by, in the tables you can find a 10, right? You can find a 10, and then you multiply by I 12 over I. So this part here, we can find it from the tables, and this would be this. That would be that. Because if you remember, we had said when we were carrying out these computations in the tutorials, we said ANP is equal to AN by IP over I. So this is this part here. And this would be equal to, this would be equal to 80,000. Now get what you can get from the tables. This R is capital R, so this would be 12R by 6.7101 from the tables for 18 times 1.036157 is equal to 80,000. So this gives us R is equal to, you then divide 80,000 by everything there. 80,000 divided by, so you can just copy this and paste it here and remove the R. And this is 80,000 divided by this whole thing. So we can copy this, you just put an equal sign and paste and enter. You get your solution. So you see how typing in Word and then going to Excel and the like helps you to get your answer faster. So we now have our answer 958.857. That's your R. So you go down here and write R is equal to, then paste your solution. This would be your answer for R. So you're done with this part of the question. Now we go to part 2. Part 2 of the question. Okay, part 2, what does part 2 say? Calculate the amount of the loan outstanding on 1 November 2018, immediately after payment of the installment then due. So from 1 January 2016 to 1 November 2018, we have the remaining term in a 10-year loan would be 7 years and 2 months. So we come here, the remaining term at that point is 7 years and 2 months. So the loan outstanding using the prospective reserve approach would then be L is equal to L denoting the loan outstanding. We said 12R, so it's just this, but it will now be for 7 years, 2 months. So this would be 12 by your R of 958, 12 by 958.8578 by A. So this would be by this one. We are writing this A 12, 7, and 2 over 12. We are going to write it using notation that's required in an exam. So this would then be A 12, then 7 and 2 over 12. 2 over 12, that's 1 over 6. Let's see. This is equal to 1 divided by 6. 0.1667. So this would be 7.1667, like this. And this is at 8%. And we can't find this in the table, so we have to use we have to determine it from basic. So this is 12 by 958.8578 by your A12 7.1667, you can write it as 1 minus V to the power 7.1667 over I over, and this is over I12 over I, this part. Let's see, this is 12 over I12, sorry. So this would be, okay, let me just write it here so that you see. This can be written as 1 minus V to the power 7.1667 over I12, which we can get from the tables, our I12. So this would be your formula, and we want to write it as you would write it in an exam. So this would be 1 minus, okay, something going on here, my computer is frozen. All right, this is 1 minus V is 1.08 to the power negative 7.1667, then close all brackets, divided by your I12. You can get it from your table, 0.077208, and you take all this, copy, put it in Word, paste. This is your answer, 63180.83. Copy it and put it here. This would be your solution in your answer booklet. And we now move on to part 3. So for part 3, we start with, on 1 November 2018, immediately after payment of the installment, the borrower asked that the monthly installment be reduced to 900 from 958, and the remaining term extended as required to clear the outstanding loan amount. The final payment should be equal to the outstanding loan at the time. If less than £900, the lender agreed to this change subject to the following conditions. The interest rate applied in future is increased to 9% per annum convertible monthly, and an administration fee of £250 is paid to the loan outstanding at 1 November 2018. 3A, determine the new date on which the loan will be repaid, and then calculate the final installment paid. So the first part is to determine the new date. So now, because we have been given an interest rate of 9% per annum convertible monthly, we can then use months instead of years. So here the first part is, we've been told that I12 is equal to 9%. So our effective monthly interest rate, effective monthly interest rate, would then be equal to 9% divided by 12, which is equal to 0.75%. That's the interest rate that we are working with. Now we want to determine when the final payment will be made. So what we don't have is the term. So to determine that term, we can say, yeah, I'm going to write using a pen. And like I mentioned before, what I write using a pen is just for you to understand what we are going to be writing in an exam. So this would be 900 AN, because we don't know what the term is. This is what we want to know. Should be greater than the amount remaining of 63,180.83 plus your 250, because there is an additional 250 required, and this is at interest rate of 0.75%. So in an exam, you would write this as You write this as 900 by an, we don't have the n, is greater or equal to 63, sorry, undo, greater or equal to 63,180.83 plus 250. And this would be 900. We can move the 900 to the other side, divide this side by 900. So this becomes a an can be written as 1 minus v to the power n divided by I, which is 0.0075 is greater or equal to your 63180.83 plus 250 divided by 900. And this one you can just copy it from here and put it in Excel. This is equal to that. This is 70.4787. So this will then be 70 point that. So this would be, if we leave v to the power n here alone, this would be v to the power n is greater or equal to 70.4787. If I'm not mistaken, I should just have copied it. Okay, that's it. Times, you multiply by this 0.787, 0.0075, 0.0075, and this is 1 minus that, because to get v to the power of n as the subject, you'd need this. So we copy this and then we paste it here. This is equal to that. And our next line would then have v to the power n is greater or equal to 0.471410. And the next part is v to the power n is just the same as saying, when we say v to the power n, we can write it as 1 over 1 plus I, 1 over 1 plus I to the power n like this. Or the easier way would be to introduce ln to both sides. If you introduce ln to both sides, this would be ln v to the power n. Ln v to the power n is greater or equal to your ln of this. And then using the laws of logarithm, this is n ln v is greater or equal to ln that. And if we leave n this side, then be n is greater or equal to this ln here, copy, paste it, divided by your ln of v. V is just 1 over 1 plus I. 1 plus I is 1.0075 to the power is to the power 1. So it will be like this. And if I copy this, put it here, this is equal to that, we get 100.646 months. So our n is greater or equal to 100.646. So it means the loan will be repaid in 101 months. So therefore the loan will be repaid in 101 months. We have our solution from 1st November, from 1 November 2018, and 101 months after that, then means the final payment will be on 1 April 2027. Now we move on to part B of the question. Part B of the question, what does part B say? Part B says calculate the final installment paid. So we can calculate the final installment to say we can use the equation of value, starting with this amount that we got here. This would be the total amount payable. How much is it? So this is equal to 63,430.83. So we say this amount here, 63,430.83 is equal to, we have 900 for the first 100 months. So this would be 900 by A 100. We now know that what A 100 is. This is annuity. Plus your X would be the final payment by V to the power of 1 or 1, because it has to be discounted to date. And we can then find your X. You can then find your X because we have our 100. So this would be, make X the subject of the formula. This would be X is equal to, okay, it's equal to 63,430.83 minus this part here, minus 900 by 800 from your tables, it's 70.1746 divided by V to the power 101. Our V to the power 101 is 0.470164. This would be your X. So X is equal to, copy this, copy, put it here, paste. This is 582 pounds. So that's your final installment. 582, this is your X. So we are done with the first question. Now we move on to the second question. Our second question is from September 2019. September 2019, I have our paper. September 2019, question number 8, question 8. This is our second revision question. So let's go to the question. It reads, a loan of £1 million nominal is issued with coupons payable half yearly in arrears at a rate of 9% per annum. The loan is to be redeemed at 110 per 100 nominal on a single coupon date between 20 and 25 years after the date of issue inclusive. The date of redemption is at the option of the borrower. An investor who is liable to income tax at 15% but not liable to capital gains tax wishes to purchase the loan at the date of issue. Calculate the price the investor should pay to ensure a net effective yield of at least 8% per annum. So in this case, we want to look at the worst case scenario. The worst case scenario would be if there is capital gain. And if there is capital gain, it then means the loan is redeemed at the latest date. And if there is no capital gain, then the worst case scenario would be the loan would be redeemed at the earliest date. So the first thing that we have to do is we can determine if there is capital gain. So the first part is there capital gain? Is there capital gain? And to determine if there is capital gain, we would look at I2 because this is paid twice a year. So if I2 is greater or equal to the dividend over redemption times 1 minus your income tax, then there will be capital gain. So let's first of all find our I2. This is small I. This is I2. And your I2 is equal to our effective annual rate is 8%. So this would be 2 times 1.08, 1.08 to the power 1 over 2, 1 over 2 minus 1. This is how you get your I2. We put it on Excel. And this is 0.07846 and paste it to your answer. This would be your I2. Now if we need to find D over R by 1 minus tax, 1 minus income tax. So this is your D, it would be 9 divided by 1.1 times 1 minus T, 1 minus 15%, 0.85. And copy this, put it in Excel. This is a percentage. So this would be your percentage here. Okay, percent. And you see here your I2 is greater than is greater than that. So since copy, say since this is greater than, copy, this is greater than that, is greater than that part, then there is capital gain, and the loan will be paid, and we assume assume redemption occurs at the latest date possible. So in this case, working with 100 nominal, our price would then be this would be 1 minus T, 1 minus 15% by our coupon rate per 100 nominal, 9 times our annuity. This is A12 because it's paid monthly and it's for 25 years, worst case scenario, plus 110 V to the power 25. and this will be equal to 1 minus 15% by 9 by that part, and this we can get it from your tables and this part too. So this would be an easy one. So this would be 0.85 by 9 by, from the tables we get a 25 by I2 over I plus 110 by v to the power 25. And this you can get it from the tables, this you can get it from the tables, and this you can get it from the tables. This is a small I. And this will then be 83.264 plus 16.062. Copy this, copy, put it in Excel, paste. So this would be your price per 100 nominal. So this would be that per 100 nominal. And this is 1 million nominal. So for whole loan is 1 million nominal, and if this is per 100 nominal, this will then be for whole loan. This is 993260, and this would be your solution. And we move on to part 2, part 2a. What does part 2a say? The investor purchases the loan for the price calculated in part 1. Exactly 10 years later, immediately after the payment of the coupon then due, a second investor who is liable to income tax at 25% and capital gains tax of 35% purchases the loan for a price such that the first investor obtained a net effective yield of 8% per annum. The second investor holds the loan to maturity. Calculate the price paid by the second investor. That's the first part. Calculate the price paid by the second investor. So in this case, the loan was left with 15 years, right, from the 25 years initially. So the price would then be equal to, we said the it takes 1 minus 15% is 0.85. So it's just this same formula here, but the only difference is we are now using a term of 15 years, so we can just copy it in an exam instead of typing it again, replacing 25 with 15, like that. We've just replaced 25 with 15, and you can get it from the tables like we did in this part. Copy, paste this part here, we can get it from the tables, and this part we can get it from the tables, and giving us a solution of 101.44. This would be your price paid by the investor. And then we move on to part B. Part B says calculate the minimum net redemption yield year end by the second investor to the nearest 0.1% per annum. So the second investor, we've said that they have the income tax of 25% and then the capital gains tax of 35%, and this is for 15 years. So we are assuming the latest possible date because there is capital gains. since the price is 101 for 110. So this would be 101, the equation of value, 0.44 that we got here. The price is equal to the second investor, their income tax rate, we've been told, is 25%, and the capital gains 35. So this would be 1 minus 25% by 9 by A15, A12, 15 plus your 110 V to the power 15. But in this case, for the second investor, because they pay capital gains tax, we have to subtract the capital gains that tax that they're going to pay, and it's 35%. So this would be 0.35 by 110 minus 101.44, because the capital gain per 100 nominal is 110 minus 101, and then discount it 15 years at rate of interest I. The I is the one that we want. So in this case, we know that the redemption yield for the second investor would be lower than 8%, because they also pay capital gains tax. So we can try out I of 7%. So in this whole equation, if you try an I of 7%, we can get all this from the tables. At interest rate of 7%, if this I is small I, if I undo is equal to 7%, then we can get the right hand side of this equation being 101.319, and then if I is equal to 6% with an I of 6%, if I is equal to, try something lower, we get 111.176. So we then interpolate between the two. And if you look at this I of 7%, 101.319, this is very close to 101.44. So we don't even need to interpolate. We can then say our interest net redemption yield, net redemption yield is equal to 7%, because we've seen this. If it had been very different from this one, we would have needed to interpolate. So our answer is 7%. So we are done with the second question on loan schedules. Our third question is from September 2020. September 2020, question number 8. That would be our third question for today. So we go to September 2020, question number 8. A loan is to be repaid by a series of installments made annually in arrears. The first installment is 200 per annum, and thereafter installments increase by $15 each year. The installments are paid for 16 years and are calculated using an effective rate of interest of 5% per annum. Calculate the amount of the loan. And in this case, it's 200 per annum for the first year and increasing by $15 per year. This is an increasing annuity, increasing by $15. So we have an increasing annuity of 15, and then the annuity of 185. So we can write it here. The equation of value for question 1, our first part of the question, would be the loan. We want to determine the loan. So the loan will be equal to your 185 A16. This is A16 because this is 16 years. This is 16 years at 5% per annum interest, plus your 15. Your 15 is increasing annuity for 16 years too. And our interest rate is 5%. So at 5% interest rate at 5%. So we can then use our tables to find A16 and A16. This can be found from the formula booklet. So this would be 185 times 10.8378 plus 15 by 80.9975 from the tables, and we copy this and we paste it here, and this is our answer, 3219.96. Copy it, and this would be your solution, 3219.96. So this is your answer for part 1. Now we move on to part 2. What does part 2 say? Construct a loan schedule that shows the capital and interest elements included in and the amount of loan outstanding after each of the fifth and sixth installments. So to determine the interest payment in the fifth installment, we should know the capital outstanding after 4 payments, after the fourth year. The capital outstanding after 4 payments is what we want to determine. So it will be the fifth payment up to the end. And to get the fifth payment, it will then be equal to your 185 plus your 15 by 5. So our fifth payment is 260. So we come here and write a fifth payment is equal to 185 plus 15 by 5. 185 plus 15 by 5, which is equal to 260. And then the capital outstanding after fourth payment, we'll be starting with the fifth payment. This will then be equal to 260 minus 15. This is 245 AE. The installments left will be 12. This would be a 12 plus your 15 IA 12. So this would be equal to 245 by, you can get it from the tables, A12 and IA12. So this would be 8.8633 8.8633 plus 15 by 52.4873, and copy this, copy paste it in Excel. You get your answer, 2958.818. So this would be your solution for the capital outstanding after the fourth payment. Now want to come up with the loan schedule. The easier way would be to come up with the loan schedule in Excel and then copy it here. So we have your year, we have our year 5, 6, and 7. We want the 3 years. And your capital outstanding at start of the year, we can denote this as, this is your A. And for the first year, we found it to be 2958. So we just put this here, 2958. And then the installment For the fifth year, we said it's 260, we write it here. For the sixth year, this will be 260 plus 15. It will be 275 plus 15, 290. And then this would be your installment. And then the interest. So our installment is here. Let me just do this so that we can see everything clearly. So our interest payment, we said our interest rate is how much is our interest at 5% per annum. So our interest payment would be, we can call it B. Yes, so B is equal to this by 5%. This would be your interest each year. We can drag it down here. So below here we can write here B. Okay, and then our capital repaid. This would be our C. So our capital is the installment minus interest. Write it like this. And then the capital outstanding at end of the year. This is our D. We can write it as equal to, this would be a capital outstanding at the start minus your capital repaid. So we drag it down here. And at the start of the second year, of the sixth year is the outstanding at the end of the fifth year. So this is and we drag it down here. So we now have our loan schedule. So this would be our loan schedule. So our loan schedule, we can put it like that. So below this, we can then just write to say interest is equal to your A by 5%. Then your capital repaid is equal to installment minus interest. And then your capital outstanding at year end is equal to capital outstanding at start minus capital repaid, just to make sure you get all the marks available. Then the third part of the question reads, calculate the capital and interest element of the final installment. So the final installment is in 16 years. And we know that this would be equal to your 185 plus 15 times 16. So the final installment is 425. So the final installment is 425. It's 425. And the loan outstanding at the start of that year is just the discounted value of 425. So the loan outstanding at start of final year will be equal to 425 divided by 1.05. This is equal to that. This would be 404.76. So this would be equal to 404.76. Then that would be the loan outstanding at the start of the year. And the capital paid, which is the capital paid in the final payment. So capital paid in final is equal to that. It's just 4.716, which means interest will be equal to the final installment minus 425 minus 404 minus the capital paid. So copy this, go to Excel, paste 20, we get 20.238, 20.24. So your interest is equal to 20.24. So we are done with the question. We are done with this question. Now we move on to the next question. Our next question is from April 2021, question 8. April 2021, question 8. Question 8, and still the Institute and Faculty of Actuaries. So our question reads, on 1 January 2022, a student plans to take out a 10-year bank loan for 15,000. Under the repayment schedule, installments will be paid monthly in arrears until the end of the term. The first installment at the end of January 2022 will be X, and the second installment at the end of February 2022 will be 2X, and so on until the installment at the end of December 2026, which will be 60X. The remaining installments from the end of January 2027 will also be 60X. The bank will charge a rate of interest of 12% per annum effective. Write down an equation of value to calculate your X. Write down your equation of value to calculate your X. So we want to calculate our X, the equation of value. And we've been told that this is a 10-year loan, and the first 5 years from 2020 to 2026 December, it's an increasing annuity. And then from there, it then becomes a level with installments of 60X. So we can write it 1. The equation of value would then be 15,000, which is the loan amount, is equal to your X being an increasing annuity for 60 months, plus it becomes level at 60X, and this we can discount it for the first 60 months, and this is an annuity for 60 at interest rate, we can call it J. At J is equal to our interest rate. This would be IE 12 over 12. So this would be at J is equal to IE 12 over 12. This would be our interest rate that we will be working with. So J is equal to 1.12 to the power 1 over 12 minus 1. 1.12 to the power 1 over 12 minus 1. Copy this. Let me just paste it here, which will be 0.00949. Copy it. This is our J, our interest rate that we will be using. And now we move on to part 2. We've determined the equation of value. Part 2 reads, calculate the value of X using the equation of value in part 1. Now we want to calculate the value of X. So our equation value remains, it remains the same. So this is our equation of value, right? You copy it, you paste it here. This would be your equation of value. So the first part is you want to find this, because our interest rate is 0.009488793. We can't find this from the tables. We can't find this from the tables. We can't find this from the table. So we have to determine these values. So okay, the first part would be determining IA60. So our IA60, if you remember, this part that I'm writing with a pen, you don't write it in an exam because you can't use a pen. I'm just writing it for illustrative purposes. So this is our IA. Okay, our A should be this small one so that it's not confusing. This is IA. IA 60 will be equal to A Ju 60 minus 60 V to the power 60 over your J, this J that we got here. So in an exam, you would then write it as IA 60 is equal to A Ju 60 minus 60 V to the power 60, then divided by everything, divided by J, which we then write it as A Ju 60. We can write it. We start with A Ju 60. This is 1 minus V to the power 60. Our V to the power 60, this is 1.30 to the power 60. So we write this to the power negative 60 to the power negative 60 and divided by, this would be divided by D, which is I over 1 plus I. So this is divided by this here, copy 0.that divided by 1.1 plus I. This would be your A Ju, and then minus 60, A Ju minus 60 by V to the power 60, which is 60 by 1 point this to the power negative 60, like that. And then the next part, I forgot to close this bracket here. So we close this one. Now we close the last bracket and then divide by 0.09. Then copy this whole formula here, put it in Excel. This time let's see, my Excel didn't read this. Yes, our solution here, we get it in Excel, and this would be your IA60. Now we want to find the next part. Sorry, this is uh this is A60 because it's for 5 years too. So this is A60. So now we want to find A60. We want to find A60, and this would be easy. This would be A60. This is small A60. A60 is just taking this part here. This is because A60 and A60, the difference is the denominator. So to get our A60, we just take the AU formula, 1 minus that divided by the denominator is just now J. And this case, copy this and paste it here. Okay. So this is your A60. You get your A60. And we now have your IA60, and we have our A60. Now we can just input it all in our formula, this formula here. So this becomes our formula. Copy it here, paste it there. So where we had IA60, we are copying this and replacing. We are now replacing, this is times, this is x times 1 something, and then this is 60 times x, 60 times x times v to the power 60. V to the power 60 is just 1.00. Let me copy it here to make it faster. This is our copy, paste to the power negative 60 by AU60. This is our AU. Copy it, not AU, A60, sorry. Paste it there. And then we make X the subject. So if you make X the subject, our X will then be equal to your 15,000, divided by, in this case, before we get here, just so you see how we got here, we can write 15,000 is equal to, make X the subject here. So if we make X the subject here, we will be left with this part. Copy here, paste it here, plus this whole part here. Copy here, paste it here, remove this X. So we can copy this one, copy, compute, this is equal to that 2814. So this would be 15,000 is equal to 2814 X. So our X will then be equal to 15,000 divided by 2814. So X is equal to, our X we say it is equal to 15,000 divided by that. So our X is 5.33. So this would be your solution. This is our X. We are done with this part. Now the last part of, the next part of the question. Our next part of the question, part 3. Our part 3, what does it say? Write down an equation to calculate the loan outstanding after the installment paid at the end of 2026 using the retrospective method. So the retrospective method will be accumulating the past payments and okay, so this would be the retrospective method. We'll be looking at what was done in the past. So the loan outstanding at the end of December 2026, we said it will be the accumulated value of the loan minus the accumulated value of the payments made to date. So as at December 2016, we only had the increasing annuities. So the loan outstanding will be equal to, this is equal to your 15,000, the loan value, and you accumulate it to December 2026, which is after 5 years, using your annual interest rate. So this is 1.12 to the power 5 minus the installments made so far, 5.33 by increasing annuity, this would be 60 installments made times 1.12 times 1.12 to the power 5, because this part we have discounted, and then accumulate to the end of 2026. So this is the equation. And then calculate the loan outstanding after the installment at the end of 2026 has been paid using the equation in part 3. So we come here, this is the equation, copy it, and this would be your part IV. And what needs to be changed is IA60. We have computed IA60 before. We just copy it from here, copy IA60 and paste it here. And then copy, this is equal to, this is 15,000 by 1.12 minus 5.395, 5.33 times, here I left the times sign, times, let's see, 15,000. Okay, let me go back here. There's something wrong with the formula here. 15,000 by 1.12 to the power 5, right? Minus 5.33 times 126,199 times 1.12 to the power 5. Let me copy this and paste it here. This is equal to that. Okay, this is minus. What's wrong with this formula? Okay, here we got the answer, 14,580. And okay, so our answer would be, this is equal to 14,580. So this would be our solution. And then the next part, and you can see that the loan outstanding after the 5th year is 14,580. which means not much has been paid of the loan because the initial loan was 15,000. So the next part, part 4, part 5, comment on your answer to part 4. And as you can see here, the loan has been paid a very, very small amount. Why is it that? We comment on that. So as interest exceeds the repayments at early durations, because at early durations, the repayments are very small. So as interest exceeds repayments at early durations, the loan outstanding will increase. Repayments will only start to reduce loan outstanding once the repayments increase beyond a certain point, and therefore, by halfway through the loan, the outstanding balance is reduced very slightly, and therefore, little of the initial loan has been paid off. That would be your part 5. Now we move on to part 6. Part 5 is theoretical. I'm not going to write the solution here. Theoretical. I've explained it. Now move on to part 6. What does part 6 say? Write down an equation to calculate the total interest paid during 2026. The total interest paid during 2027. So during 2027, the installments now are now 60x. They are now 60x. That would be the installments. So we can calculate the interest repaid during 2026 by saying the total repayments made minus the capital that would be paid. So how do we determine that? So let's calculate this. So interest paid during 2027, interest paid during 2027, the question says calculate the total interest paid during 2027 using, write down the equation. So it says write down the equation to calculate the total interest paid during 2027. So the total interest paid during 2027 will then be the total repayments minus the capital repaid. And we can write the equation as the total repayments interest paid would be equal to the total repayments less capital repaid. So the first part would be getting the total repayments will be equal to 12, because these are 12 payments made during the year monthly, times 60x, times your 60x, and we know our x is 5.33. And then the next part is the capital repaid. So capital repaid will be equal to capital outstanding at December, loan outstanding at December 2026 minus capital outstanding at December 2027. And your capital outstanding at December 2026, we have computed it in the last part. This would be at December 2026, we computed it here, our 14,580. This is equal to 14,580. And then we want capital outstanding at December 2027. which we can, because as at December 2027, the payments now being made per year are 60x. And that would be 12 per month, sorry. The payments that are now being paid per month are 60x. So as at December 2027, you'll be left with 4 years of the loan, which is 4 times 12, 48. So it will then be 60x a 48, because you'll be left with 48 installments. So our equation, interest paid during 2027, we now have the different components, will then be equal to 12 by 60x, copy, minus the capital repaid, which is this, minus 14.580, sorry, paste it here, which is minus 60x a 48. That would be your equation. And the next part reads, calculate the total interest paid during 2027 using that equation. So we want to then use that equation. So 12 by 60x minus that is how we want to calculate 12 by 60x minus 14.58 minus 60x a 48. Now we want to calculate the interest paid. So the first part is this part here. We want to simplify it. So this would be equal to 12 by 60 by our x, which is 5.33 for it. Paste it here, 3837.6. So this would be our answer. Let me copy our answer and paste it here. This is this part, and then we want to compute this part. This will be equal to, this will then be 60 by our x of 5.33 by our a 48, which is 38.411.832.3216. And we can copy this, paste it here. We get our answer 12284. This is equal to 12284. So our interest paid during 2027, it will then be equal to 12 by 60x, which is this, minus 14,580 minus 12,284, and copy this, paste it here. This should be negative. So this is our answer, 1540.80. So our answer, this would be our answer. This is our answer. This is the interest paid during 2027. Now the last part. The bank also offers the 10-year loan with the same interest rate, but where the monthly installments remain level throughout the term. Comment on whether the loan interest paid by the student under this revised offer would be greater or less than that paid under the original repayment schedule. You should not perform any further calculations. So in this case, if the installments are level, it then means more of the loan will be repaid earlier because the installments are level. So more and a greater amount of the loan will be repaid earlier. And if more of the loan is repaid earlier, it then means that less interest is paid because any outstanding amount in the latter periods will be less. So less interest will be paid compared to under the original arrangement. So we are done with this question. Now we move on to the last question. Our last question is September 2022, question 11, and it reads, a loan of £300,000 was taken out on 1 January 2015. The loan is repaid by an annuity payable quarterly in arrears for 12 years. The amount of the quarterly installment increases by £400 after every 4 years. The installments were calculated based on a nominal rate of interest of 6% per annum convertible quarterly. Assuming the equivalence principle applies, state an equation of value which can be used to calculate the initial quarterly installment. So here we are working with quarters and we have a nominal rate of interest of 6% per annum converted quarterly. So it means our effective rate of interest per quarter will be the nominal rate divided by 4. So we'll start with the first part. Our question is for September 2022, question number 11. Question 11. So we start with the first part. So the first thing is we want to find the effective interest rate. So our effective rate of interest is equal to this is 6% divided by 4, which is equal to 1.5% per quarter. And our question says, assuming the equivalence principle applies, state an equation of value which can be used to calculate the initial quarterly installment R. So we want the equation of value, and we've been told that the loan is for 300,000. So this would be 300,000 is equal to, for the first 4 years, we've been told the installments are R per quarter. So this would be R, and the annuity for 16 quarters because it's 4 times 4, 16 quarters. And then for the next 4 years, it's going to increase by 400. We've been told here that it's going to increase by 400, and this is a 12-year loan, so there are 3 4 years periods. So this would be v to the power 16 because we have to discount it back to times 0 by, this would then be r plus 400, the installments, and times a 16. Then the last 4 years to then be v to the power 32 by r plus 800 because it's another 400 added by a 16. That would be our equation of value. Now, using your answer to part 1, calculate R showing all your workings. We now want to calculate R. And at 1.5% interest per annum, we can find the value of A16 from the tables and your V's. from the tables. So it's then easier to find your R. So here, starting from here, we can then group like terms. So we have the parts where we have our R's. So we can then say R factor of, with R we have R A16. So this is R A16 times, open brackets, we have our 1 plus, in this part where we have R A16, it would be V to the power 16, V to the power 16, plus in this part where we have your RA16, it will be V to the power 32, which is V to the power 32, then plus the other like terms here, we would have 400 by A16, so this would be 400 by A16 times, this is V to the power 16, open brackets, V to the power 16 plus, for this part, V to the power 32. Now we can then just input from our tables. This would be R times A16 is 14.1313 times 1 plus V to the power 16, 0.78803 plus V to the power 32, 0.62099, plus the 400 by A16, 14.1313, by V to the power 16 plus V to the power 32, it's just the same as this part. Paste it here, close brackets. And so this becomes equal to, this becomes R times this part. So we can take this part here, put it in Excel, 34.04. So this would be 34.04R plus this other part here. This is equal to that 7964. Let's see, this is 400 plus 14. Okay, I left out something here. This is 800. In this part, this is 800. So this would then be 2 times. So this would be 2 times. So we go here, we then say 2 times. And we get our 11,474. So this would be 11,474. And then we can get our R. Make R the subject. It then becomes 300,000 minus 11,474 divided by the 34. Copy, paste it here, 8475. So this would be your R. So R is equal to 8475 per quarter. Per quarter, this is your quarterly installment. Now we move on to the next part. Okay, we've determined the formula here. This was the first part, and then the second part started here. This was the second part where we determined R, and then the third part of the question, calculate showing all your workings the amount of capital repaid in the first quarterly installment made on 31 March 2015. So you want the amount of capital repaid in the first quarterly installment. So the loan is 300,000, right? And the first interest payment will just be equal to the interest rate times the whole loan amount, and then we then subtract that from the installment to get the capital. So this is part 3. Part 3, so the first is the interest component of the first installment will then just be 300,000 by 1.5%. 1.5%, 300,000 by 1.5%. This is the interest. So our interest is equal to 300,000 by 1.5%, which is 4,500. So our interest is 4,500. And so the capital repaid will be the installment of 8475.42 minus 4,500, and taking this here, copy it, paste it here. Okay, this should be a minus 3975.42. So this is your answer. This is equal to 3975.42. That's your answer. Let's see. We move on to the fourth part of the question, which reads, calculate using an appropriate annuity function the amount of loan outstanding immediately after the quarterly installment due on 30 September 2022 has been made. So here we have been told that after every 4 years, the amount of the quarterly installments increase by 400. So using the prospective reserve formula, we can see that from December 22, the next installment will be 8475 that we got in part 2 plus 400, right? But then in 2023 onwards, the installment is going to increase by a further 400 from that part, and we want to find the discounted value of that amount as at 30 September. So we have the next installment, December 2022 installment is equal to 8475.42 plus 400, because it would have increased by 400, which gives us 8875. And then from 2023 onwards, installments will then be plus an additional 400. So it will be 8875 plus 400 to give us 9275.42. So this is 0.42, and this is for 4 years. This is for 4 years paid quarterly. So we want to then find the discounted value as at 30 September. So the loan outstanding will then be equal to the December 18875.42 V, because we are discounting it once, and the rate of interest is still 1.5%, plus for the next 4 years, this is 9275.42. We put a V again, and it's an annuity, right? By A, 4 times 4, A16, and we can get this from the table. So this becomes 8875.42 by our fee of 0.98522 plus 9275.42 by our V of 0.98522 by our A16 from the tables of 14.1313. You copy all this, copy and paste it here, and this would be your loan outstanding. This would be your solution for part 4 of the question. And now part 5. Part 5, what does part 5 say? Okay, that's the last part. On 1 October 2022, the borrower asked to change the loan contract such that the quarterly payments would be level for the remainder of the term. The lender agreed, provided that the interest rate was increased to 7.5% per annum effective, and that the original term of the loan is unchanged. Calculate using an appropriate annuity function the new quarterly level installment. You must show all your workings. So here we can use the equation of value to determine the new quarterly level installments. And here we've been given the annual effective rate. So we have to determine the quarterly effective rate. So the first thing is to determine the quarterly effective rate. And as at 1 October 2022, we are left with 17 installments. So the quarterly effective rate will be equal to 1.075 to the power 1/4 minus 1. Copy this. Let me put it here. So this is your quarterly interest rate that we are going to be using for this part of the question. This is 1.8245%. And so our equation of value, we start with the loan outstanding 137880. This is our loan outstanding, and equate it to, so the quarterly payments, let's name it the new one, let's name it W. So we can write that let W denote the new quarterly installment. Quarterly installment. So this would be then W by, this is an annuity for 17 periods. An annuity for 17 periods. So this becomes, because the interest rate is 1.8%, we can't find this from the table. So we have to determine it from first principle, which is 1 minus V over I. So this is 1 minus our V, it's 1.018 to the power -1. So this is this to the power -17, to the power -17 divided by our I here. And we can copy this part, copy it, put it on Excel, paste it. 1 minus, oh sorry, V is 1 point, copy it. So it's 1.018244 to the power -16. So this would be our answer. So this would be 14.5038 W is equal to 137,880.714. So here we then say W is equal to 1337 divided by 14.5. This would be your W. So 9506 would be your W. W is equal to 9506 per quarter. Okay, that brings us to the end of the question. So this is how you compute questions on loan schedules in an exam. Thank you for your time, and if you have any questions, you can post them on Classroom, and then I'll be able to assist. Just make sure that for revision, please use Microsoft Word. Thank you.